Find the derivative of y is equal to tan x from first principle. Y equal to tan x. Okay. F dash x is equal to, let it be f of x. F dash x derivative is equal to f limit h tends to 0 f of x plus h minus f of x divided by h is equal to limit h tends to 0 tan of x plus h minus tan x divided by h equal to limit h tends to 0 tan x plus h is sin x plus h by cos x plus h minus sin x by cos x divided by h equal to limit h tends to 0 sin x plus h into cos x by cross multiplying and simplifying minus cos x plus h into sin x divided by cos x plus h into cos x. See, divided by h become into 1 by h. Okay, that's equal to limit h tends to 0. The sin x cos y minus cos x sin y is sin of x minus y, that is x plus h minus x. Okay, divided by cos x plus h into cos x into 1 by h. So here x cancelled. That's equal to limit h tends to 0. Here numerator is sin h by denominator cos x plus h into cos x into 1 by h. That's equal to limit h tends to 0 sin h by h into 1 by cos of x plus h into cos x. So taking the first limit, it is sin limit h tends to 0 sin h by h is 1 into 1 by here cos when h tends to 0 which is cos x into cos x, that is 1 by cos square x which is equal to c square x. So derivative of tan x is c square x. Next one, limit x tends to 2. First part, limit x tends to 2 x raised to p minus 2 raised to p by x minus 2 equal to 192. So by standard result, left hand side is n into x raised to n minus 1 or n into a raised to n minus x tends to a. So p into a is 2 raised to p minus 1. Okay, that is equal to is equal to 192 is 6 into 32. Okay, that is p into 2 raised to p minus 1 is equal to 6 into 2 raised to 6 minus 1. This 32 is 2 raised to 5, so 2 raised to 5 into 6. So comparing p is equal to 6. So that is the first part. Now second part, limit x tends to 0 root of 1 plus x minus 1 divided by x. Okay, that's equal to limit, see, put 1 plus x equal to y. So when x tends to 0, y tends to 1. So this is y tends to 1 root 2y minus 1 divided by x is here from this equation x is equal to y minus 1. That is limit y tends to 1, which is y raised to half minus 1 raised to half by y minus 1. So that is half into 1 raised to half minus 1. Okay, that is half into 1 raised to minus half. That is equal to 1 by 2. 1 raised to minus half is 1. Okay. Next one. Sorry. See the third part. Third part. Limit x tends to 0. Sine ax by x into cos bx equal to limit x tends to 0. This is sine ax by x. We multiply the denominator by a and a numerator by a into 1 by cos bx. Okay, so limit of this function is equal to 1. So a is a constant taken outside. Limit x tends to 0, sin x by x is 1. Now 1 by, when x tends to 0, which is cos of b into 0 now. That is a into 1 by cos 0. Cos 0 is also 1. So which is equal to a. Next one. First part. Limit z tends to 1. Limit z tends to 1. Root z minus 1 by 1 minus z equal to limit z tends to 1. Root z is z raised to half minus 1 can be written as 1 raised to half by negative of z minus 1. Okay. It is minus half, minus 1 into x raised to n minus a raised to n by x minus n. So n is replaced by half. Half into 1 raised to half minus 1. That is minus half into 1, which is equal to minus half. Okay. Now second part. Limit x tends to pi by 4. Limit x tends to pi by 4. Tan of pi by 4 minus x by pi by 4 minus x equal to, see, put pi by 4 minus x, put pi by 4 minus x is equal to y. Now when x tends to pi by 4, y tends to 0. So it will become limit y tends to 0 tan y divided by y. So limit y tends to 0 tan y divided by y is equal to 1. Okay. Now the third one. Limit x tends to 0. F of x divided by x square is equal to k, where k not equal to 0. Then limit x tends to 1 f of x. Then limit x tends to 1 f of x. Okay. So limit x tends to 1 f of x is when x tends to 0, this function is, the limit is not defined. Then limit x tends to 1 f of x is not defined. Okay. Now using the first principle of derivatives, find the derivative of 1 by x. So let f of x is equal to, let f of x equal to 1 by x. F dash of x equal to limit h tends to 0 f of x plus h minus f of x divided by h, that is equal to limit h tends to 0 1 by x plus h minus 1 by x divided by h, that is equal to limit h tends to 0 x minus x plus h divided by x into x plus h divided by h equal to limit h tends to 0 x minus h by x into x plus h into 1 by h. Okay, that is equal to limit h tends to 0. Here minus h divided by x into x plus h into 1 by h. H cancelled. So limit h tends to 0. Minus 1 divided by x into x plus h. So when h tends to 0, h is equal to 0, which is 1 by minus 1 by x square. Next one, using the quotient rule, find the derivative of fx is equal to cortex. F of x is equal to cortex, that is f of x is equal to cos x by sin x. F dash x by quotient rule, denominator into derivative of the numerator minus numerator into derivative of the denominator, the whole divided by denominator square. Okay, that's equal to sin x into derivative of cos x is minus sin x minus cos x into derivative of sin x is cos x, the whole divided by sin square x, that is minus sin square x minus cos square x by sin square x, that is equal to minus of sin square x plus cos square x by sin square x, that is minus 1 by sin square x is equal to minus cosec square x. Okay. Next, find the derivative of the following. First one, f of x equal to 2x plus 3 divided by x minus 1. F dash x equal to, by quotient rule, denominator into d by dx of 2x plus 3 minus 2x plus 3 into d by dx of x minus 1, the whole divided by x minus 1 the whole square, is equal to x minus 1 into derivative of 2x plus 3 is 2. Okay, minus 2x plus 3 into derivative of x minus 1 is 1 by x minus 1 square. So 2x minus 2 minus 2x minus 3 by x minus 1 square. 2x cancel, minus 5 divided by x minus 1 square. Okay. Now the second part, f of x equal to cos x minus 5. Okay. Cos x minus y is cos x cos 5 plus sin x sin 5. Now f dash x is equal to, here the cos 5 is constant, so constant into d by dx of cos x plus here sin 5 is constant, d by dx of sin x. Okay, that's equal to cos 5 into cos x derivative is minus sin x plus sin 5 into sin x derivative is cos x. Okay, so that is equal to cos x sin negative can be taken outside, so negative of sin x cos 5 minus cos x sin 5, that is equal to minus, which is sine of x minus 5. Okay. Next one, prove that d by dx of cos x divided by 1 plus sin x is equal to minus 1 divided by 1 plus sin x. So which is equal to, can apply the quotient rule, denominator 1 plus sin x into d by dx of cos x minus cos x into d by dx of 1 plus sin x the whole divided by 1 plus sin x the whole square. That is 1 plus sin x into derivative of cos x is minus sin x minus cos x into 1 plus sin x derivative is cos x the whole derivative 1 is 0 and derivative sin x is cos x. 1 plus sin x the whole square. Okay, so simplify this bracket. Minus sin x minus sin square x minus cos square x by 1 plus sin x the whole square. Okay, that's equal to minus sin x. Now negative taken outside, sin square x plus cos square x by 1 plus sin x the whole square, that is equal to minus sin x minus 1. Sin square x plus cos square x is 1, so 1 plus sin x the whole square. So negative taken outside, 1 plus sin x divided by 1 plus sin x the whole square. 1 plus sin x is cancelled, minus 1 divided by 1 plus sin x the whole square. Okay. Next one, find the derivative of y is equal to Cortex from first principle. That f of x is equal to Cortex. Okay, f dash of x is equal to limit h tends to 0 f of x plus h minus f of x divided by h. That's equal to limit h tends to 0 cot of x plus h minus cot x divided by h equal to limit h tends to 0 cot x plus h is cos x plus h by sin x plus h minus cos x by sin x divided by h equal to limit h tends to 0 cos x plus h, cross multiplying cos x plus h into sin x, or sin x into cos x plus h, sin x cos x plus h minus cos x into sin x plus h, that divided by sin x plus h into sin x into 1 by h. Okay, is equal to limit h tends to 0 sin x cos y minus cos x sin y sin of x minus x plus h. Okay, by sin x plus h into sin x into 1 by h, that is equal to limit h tends to 0 sin of minus h divided by sin x plus h into sin x into 1 by h, that's equal to limit h tends to 0 sin of minus h is minus sin h minus 1 divided by sin x plus h into sin x into sin h divided by h. So sin h divided by h, taking the limit as h tends to 0, it is 1. So minus 1 by here sin x into h tends to 0, sin x into sin x, sin square x into 1 is equal to minus cos square x. Okay. Next, first part, the value of limit x tends to 0 sin x divided by x, which is equal to 1. Now second part, evaluate limit x tends to 0 sine 4x by 3x, that is equal to 1 by 3 can be taken outside. Limit x tends to 0, sine 4x by x, we multiplying and dividing by 4, so 4 by 3 into limit x tends to 0, sine 4x by 4x, that is 4 by 3 into 1 is equal to 4 by 3. Okay. Now first part, limit x tends to a, x raised to n minus a raised to n by x minus a equal to n a raised to n minus 1. Now second part, limit x tends to 1, x raised to 15 minus 1 by x raised to 10 minus 1, that is limit x tends to 1, we dividing the numerator and denominator by x minus 1. So x raised to 15 minus 1 by x minus 1, x raised divided by x raised to 10 minus 1 by x minus 1. Okay, that is equal to, this 1 can be written as 1 raised to 15. This here the denominator 1 can be written as 1 raised to 10. So apply the formula, first formula in the numerator. So n is replaced by 15 into 1 raised to 15 minus 1 divided by 10 into 1 raised to 10 minus 1. So any value or any power of 1 is 1. So 15 divided by 10, 500 divided by other 3 by 2 now, 3 by 2. Okay. Now find the derivative of sin x from the first principle. F of x is equal to sin x. Sin x, f dash of x is equal to limit x tends to 0, sorry h tends to 0, f of x plus h minus f of x divided by h, that is equal to limit h tends to 0, sine of x plus h minus sin x divided by h is equal to limit h tends to 0, sin c minus sin d is 2 cos c plus d by 2, x plus h plus x by 2 into sin x plus h minus x by 2. Okay, the whole divided by h, that is equal to limit h tends to 0, 2 into cos of 2x plus h by 2 into sine of h by 2 divided by h, that's equal to limit h tends to 0, 2 into cos of 2x plus h by 2 is 2 plus h by 2, sorry x plus h by 2, x plus h by 2 into sine of h by 2 divided by h. So here we dividing the numerator by 2, sorry denominator by 2 and multiplied by 2. So these two get cancelled and the limit of this expression become 1. When h tends to 0, it will cos x into 1 and the derivative of sin x become cos x. Okay. Next find the derivative of x plus cos x divided by tan x. So let y is equal to x plus cos x divided by tan x, dy by dx equal to tan x into derivative of x plus cos x minus numerator x plus cos x into d by dx of tan x, the whole divided by tan square x. Okay, that's equal to tan x into derivative x is 1 and derivative of cos x is minus sin x, minus sin x minus x plus cos x into derivative of tan x is sec square x, the whole divided by tan square x. Okay, so tan x into 1 is tan x minus sin x into tan x. Okay, now minus x sec square x minus cos x into c square x divided by tan square x. That's equal to tan x minus sin x into tan x minus x c square x. Here cos x is 1 by sec x, so sec x gets 1, sec x get cancelled, so minus sec x divided by tan square x. Okay, find the derivative of sin x using first principle. So refer question number 11. Refer question number 11. Okay, next find the derivative of x raised to 5 minus cos x divided by sin x using quotient rule. So dy by dx is equal to denominator into d by dx of x raised to 5 minus cos x minus numerator x raised to 5 minus cos x into d by dx of sin x the whole divided by sin square x, that is sin x into 5x raised to 4 minus derivative of cos x is minus sin x minus x raised to 5 minus cos x into derivative of sin x is cos x the whole divided by sin square x. So 5x raised to 4 sin x plus sin square x minus cos x into x raised to minus x raised to 5 cos x, next is plus cos square x divided by sin square x, that's equal to 5x raised to 4 sin x minus x raised to 5 cos x plus sin square x plus cos square x is 1. This sin square x plus cos square x can be written as 1 by sin square x. Okay, so that is the derivative. Using the first principle, find the derivative of cos x. Let f of x is equal to cos x. F dash x is equal to limit h tends to 0 f of x plus h minus f of x divided by h, that's equal to limit h tends to 0 f of x plus h is cos of x plus h minus cos x divided by h, that is limit h tends to 0 cos c minus cos d is minus 2 sin x plus h plus x by 2 into sin x plus h minus x by 2 divided by h equal to limit h tends to 0 minus 2 sin of 2x plus h by 2 into sin of h by 2 divided by h, which is equal to limit h tends to 0 minus 2 sin x plus h by 2 into sin h by 2 divided by h. So here by 2 into 2, these two get cancelled. Taking the limit as h tends to 0, which is minus sin x into, here the limit is 1, so derivative of cos x is minus sin x. Okay, find the derivative of y is equal to cos x divided by 2x plus 3. dy by dx is equal to denominator into derivative of the numerator minus numerator into derivative of the denominator, the whole divided by denominator square, equal to 2x plus 3 into cos x derivative is minus sin x minus cos x into derivative of 2x plus 3, that is 2 into derivative of x is 1, that is 2 into 1 plus derivative of 3 is 0, so here it is 2 by 2x plus 3 the whole square. So minus 2x sin x minus 3 sin x minus 2 cos x the whole divided by 2x plus 3 the whole square. Okay. Next one, evaluate first limit x tends to 1, x raised to 7 minus 1 by x raised to 4 minus 1. See, here we divide the numerator and denominator by x minus 1. X raised to 7 minus 1 by x minus 1 divided by x raised to 4 minus 1 by x minus 1. That's equal to limit x tends to 1. X raised to 7 minus 1. 1 can be written as 1 raised to 7 by x minus 1 divided by x raised to 4 minus 1 raised to 4 by x minus 1. So when we apply the limit in the numerator, which is 7 into 1 raised to 7 minus 1 by 4 into 1 raised to 4 minus 1. So that is 7 by 4. Okay. Now the second part, limit x tends to 0. Cos 2x minus 1 by cos x minus 1 is equal to limit x tends to 0. 1 minus cos 2x, here we can take negative 1 outside, negative of 1 minus cos 2x divided by negative of 1 minus cos x. Okay, that is limit x tends to 0, x tends to 0, 1 minus negative get cancelled, 1 minus cos 2x is 2 sine square x by 2 sine square x by 2, these 2 get cancelled. Okay, that's equal to limit x tends to 0. See, sine square x is sin x into sin x by sin square x by 2 is sin x by 2 in sin x by 2 into sin x by 2. Okay, so that's equal to limit x tends to 0. Here we divide here by x and multiplied by x. Here also sin x by x into x divided by sin x by 2 divided by x by 2 into x by 2, again sin x by 2 divided by x by 2 into x by 2. Okay, so equal to value of this limit is equal to 1. Again value of this limit when x tends to 0 is 1. This x get cancelled. Okay, so numerator value of the limit is 1 into 1 divided by, here the limit is equal to 1 into 1 by 2 into, here also limit is equal to 1 into 1 by 2. So 1 divided by 1 by 4, which is equal to 4. Next one, first part, limit x tends to minus 1, x tends to minus 1, x square minus 5x plus 6 by x minus 1. Okay, that is equal to limit x tends to minus 1, which is minus 1 square minus 5 into minus 1 plus 6 by minus 1 minus 1. That's equal to 1 plus 5 plus 6 by minus 2 is equal to 12 by minus 2, which is equal to minus 6. So that is the value of the limit. Okay, now second part, limit x tends to pi, sine of pi minus x divided by pi into pi minus x. Put this pi minus x is equal to y. So when x tends to pi, y tends to 0. So this limit is limit y tends to 0 sine y divided by pi into y. So 1 by pi can be taken outside. Limit y tends to 0 sine y divided by y, that is 1 by pi into 1, which is equal to 1 by pi. Okay. Next, the derivative of sec x from first principle. F of x is equal to sec x. F dash of x is equal to limit h tends to 0 f of x plus h minus f of x divided by h, that is equal to limit h tends to 0 sec of x plus h minus sec x divided by h equal to limit h tends to 0 1 by cos of x plus h minus 1 by cos x into 1 by h. This h become 1 by h is equal to limit h tends to 0 cos x minus cos x plus h by cos x into cos x plus h into 1 by h. Okay, that's equal to limit h tends to 0 cos c minus cos d minus 2 sine c plus d by 2 x plus h by 2 into sine x minus x plus h by 2 by cos x into cos of x plus h into 1 by h. Okay, equal to limit h tends to 0 minus 2 sine 2x plus h by 2 into cos of minus h by 2 by cos x into cos of x plus h. Okay, into that's equal to, see here the function not cos, which is sine function. Okay, so limit h tends to 0 minus 2 sine of x plus h by 2 into divided by, here it is cos x into cos of x plus h into the sine of negative h by 2 is minus sine h by 2, here by h into 1 by h is by h. Okay, so here by 2 into 2, these 2 get cancelled. Now negative sign, so the final answer become positive. Taking the limit, numerator is sin x by cos x into 1. Now 1 by cos x, here it is 1 by cos x sec x and sin x by cos x tan x. So sec x tan x is the derivative of sec x. Next one, first part, find limit x tends to 2. Limit x tends to 2 x raised to 4 minus 4x square by x square minus 4 equal to limit x tends to 2 x square can be taken outside, x square into x square minus 4 by x square minus 4. Okay, that is limit x tends to 2 x square minus 4 get cancelled. Limit x tends to 2 x square, which is equal to 2 square, so that is equal to 4. Next one, second part, if y is equal to sine 2x, prove that dy by dx is equal to 2 cos 2x. See, can be written as sine 2x is 2 sin x cos x. Derivative dy by dx is equal to, by product rule, 2 is a constant, first function sin x into d by dx of cos x plus second function cos x into d by dx of sin x. Okay, that's equal to 2 into sin x into derivative of cos x is minus sin x. Okay, plus cos x into derivative of sin x is cos x is equal to 2 into minus sin square x plus cos square x. That's equal to 2 into cos square x minus sin square x. That is 2 cos 2x. Okay.